So doing transformations on the natural log of x, so y equals ln of x. If we go back to what the domain is 0 to infinity, so we have to know something about these things. He has a VA at x equals 0. So that's the nature of the logarithm. The argument has to be positive, so x has to be positive. X equals 0 means that's where the VA occurs. Remember, it's the inverse of the exponential. The exponential has an HA, which means the logarithm will have a VA because x and y are reversed. So what's the transformation? This is the easy part. Well, I come up here, I'm taking a logarithm of x minus 3. This is a plus 3, so what is it? What kind of? It's a plus 3. To the right 3 units. Remember, the x's are always the reverse. So if it's going to be to the right 3 units, that means I'm going to take my x values, I'm going to add 3 to all of my x values. So if I take a look at the basic function, and you say, well, what do we need out of the basic function? Well, if we remember kind of what logarithm looks like, it looks like the exponential. What I need are 3 coordinate points. I need the bend. I need the bend in the graph. This is 1, 0. So at which point I say 1, 0. I need a point to the left of 1, I need a point to the right of 1. And 1/2 will do nicely. And to the left of 1, 2. What that gives me is the bend. I have a VA at 0. Now I need those values, so I'm going to pull out my handy dandy little calculator and take the natural log of a half, which is negative 0.7, and the natural log of 2, which is just 0.7. Take 1 is where the natural log crosses, any logarithm by the way, any basic logarithm crosses the x-axis of 1. So take 1 and then you'll take a point to the left of 1, a point to the right of 1, you get the bend in the graph, just like you do with the exponential. And with the VA, then you can easily then get the graph put into place. So that says I need to add 3 to the x's. So this is going to be 3 and 1/2. 4, 5, 3. My new VA is going to be x equal 3. So x equal 3. At 3.5, I'm at negative 0.7, about negative 3/4. At 4, I'm at 0. At 5, I am about 3/4. See, there's your bend right there. It, like the exponential, goes in toward and away from. He looks like the exponential shifted 90 degrees, which is what should be the case. See, it looks like the exponential function. Why? Because you are interchanging x's and y's. So that would be the graph of y equals the natural log of x minus 3. Now again, if we look at the basic function, it's y equal the natural log of x. His domain is 0 to infinity. He has a VA at x equals 0. List the transformation. I start with the inside, and it's minus 1 times x. So what do I have? I reflect who? Reflect the y-axis. All right, because x has changed sign, so it's y-axis. And then I come to the outside, and that is what? Reflect the x-axis. Because the outside affects the y, so the y values are changing sign. So it's upside down backwards. So the first thing I'm going to do is I'm going to take minus 1 times the x values. And then I'm going to take minus 1 times the y values. This turns it backwards. This flips it upside down. So I'm going to pull my t-bar chart. So x, natural log of x. We have our 3 coordinate points, which is 1/2, 1, and 2. This is negative 0.7, 0, 0.7. Now I'm going to multiply all the x's by negative 1. Negative. Oh, thank you. I need to put the VA in. Good news is it's not going to unpack the VA, but left, right, we'll do that. Negative 1/2, negative 1, but you all should always put it in. Negative 2 and 0. Then I'm going to multiply the y values by negative 1, which is 0.7, 0, negative 0.7, and VA. So there's my new. So I have a VA still at x equals 0. So I put the VA in. That's what allows me, by the way, to use so few coordinate points. Because once the VA goes in, it's a blocker to the graph. And the bend tells you what it's going to do. Negative 1/2, positive 0.7. Negative 1, 0. Negative 2, negative 0.7. And there it is. There's the bend right there. It goes toward the VA and away from the VA. He's upside down and backwards. For those of you going to be taking trigonometry, you'll be grateful for this. For those of you taking 212, you're not going to care. Every now and then we run into things that you look at transformations and it's like, oh, well, yeah, okay.